The next chapter we're going to be studying is on ratios. A ratio is a comparison of two quantities by division. To make this concept easier to understand, let's use a fruit and yogurt parfait for an example. In this fruit and yogurt parfait, let's say there are 6 blueberries. Also, one of the fruits in the fruit and yogurt parfait is a strawberry, and let's say that there are 12 strawberries. Finally, in this fruit and yogurt parfait, there are also raspberries, and we'll say in this one there are 8 raspberries. If I wanted to bring ratios into these quantities of numbers to compare them, I could do it like this. So I could say for every 6 blueberries, there are 12 strawberries. And you can also write this in 2 other ways. You can write it with a colon in between, which is what there are here with 2 dots. You can also write it as a word phrase, so it's 6 to 12, meaning there are 6 blueberries to 12 strawberries. Or you can write it as a fraction, which looks like this, where we have 6 over 12. So for 6 blueberries, there are 12 strawberries. Now, one thing we need to mention is that ratios are often expressed in simplest form. So if we're looking at the fraction of this ratio, which is 6/12, we need to make that into simplest form. We can do that by finding the GCF of 6 and 12. Which is 6. So we can divide both the numerator by 6 and the denominator by 6. And this ratio in simplest form is 1 to 2. So for every 1 blueberry, there are 2 strawberries. So we can take our original ratio, which is 6 blueberries to 12 strawberries, and express it as a fraction, but when we express it as a fraction, we need to also make sure that it's in simplest form. So that's why we found the GCF divided by 6, and we ended up getting 1/2, or 1 to 2. So our ratio in simplest form is the same as 1 to 2. We're going to go ahead and do another example. This time we're going to use raspberries and strawberries. So if we wanted to find the ratio of raspberries to strawberries, we would look at the quantity of raspberries and the quantity of strawberries and express that as a fraction. So we could do, again, express it in 3 ways, but fraction is typically the most common. We're going to do 8 raspberries to 12 strawberries. This can also be expressed as 8 to 12 and 8 to 12 this way. Now don't forget we need to make that into simplest form. So we have to find the GCF, greatest common factor, of 8 and 12. And the biggest factor that 8 and 12 have in common is 4. So we can divide both the numerator by 4 and the denominator by 4. And we can get 2 over 3. So that ratio in simplest form is now 2 to 3, or 2/3. We can also use ratios to compare parts to a whole. So we have our total amount of fruit that's in this fruit and yogurt parfait listed here. The total amount of fruit can be found by adding up all of the fruit, and that will be our total. So if we do 6 plus 12, we get 18, and 18 plus 8 is 26. So we're going to write our 26 is the total pieces of fruit. And if you remember from our fractions unit that we had studied before, the total number of parts, or the total, is typically the denominator of our fraction. And in this case, when we express our ratio as a fraction, it's going to become the denominator of our ratio. So let's say we want to find the ratio of blueberries to the total amount of fruit in the fruit and yogurt parfait. We would do 6 blueberries out of 26 total pieces of fruit. Now we would need to simplify that, so I think the GCF of 6 and 26 is 2, so we're going to divide both the numerator and denominator by 2, and that gives us 3/13 is the ratio of blueberries to the total number of pieces of fruit in the fruit and yogurt parfait. We can also do this with the individual kinds of fruit for the other types of fruit, such as strawberries and raspberries. So if we wanted to do it with raspberries, we would say there are 8 raspberries out of the 26 total, and it looks like the GCF of those two numbers is also 2, so we divide by 2, and we'll get 4/13. So the ratio of raspberries to the total amount of fruit in the fruit and yogurt parfait is 4 out of 13. We could also say this as saying 4 out of every 13 pieces of fruit will be raspberries, or 8 out of every 26 pieces of fruit will be raspberries. And just to make sure we understand, I'm going to go ahead and do the strawberries as well. So we can say that there are 26 total pieces of fruit, and out of that there are 12 strawberries. And again, GCF is 2, so we're going to divide both the numerator and the denominator by 2. 12 divided by 2 is 6, and 26 divided by 2 is 13. So our ratio of strawberries to the total amount of fruit is 6/13. That means 6 out of every 13 pieces of fruit will be strawberries in this tasty treat. Now we just learned that a ratio is a way to compare amounts or quantities of objects or other numbers. Now we're going to learn about rates. And a rate is really like a ratio because it compares two quantities, but a rate is different from a ratio because a rate compares different kinds of units among the quantities. So I'm going to go back to our problem that we had on our dividing mixed numbers test, where that was a problem that stated that a snowboarder can travel 16 miles in 1/5 of an hour. And to make that a little easier for us, I'm going to say that a snowboarder can travel 16 miles in 20 minutes. Now this is a pretty common type of rate because it's telling how far someone travels in a certain amount of time. So if we have 16 miles in 20 minutes, we could express it as a rate or a ratio by doing 16 miles over 20 minutes. Now remember, what makes this a rate instead of a ratio is that we have different kinds of units. A mile is a unit of distance and a minute is a unit of time. So this is why this is a rate and not a ratio. Please make note that there is a difference between the two words. Now we're going to go ahead and simplify this rate by finding the greatest common factor, and the greatest common factor of 16 and 20 is 4. So that means we can divide both the numerator by 4 and the denominator by 4, and that will give us 4/5. That means in ideal conditions, that snowboarder can travel 4 miles in just 5 minutes, which is pretty amazing to travel a whole 4 miles in 5 minutes if you're just on a snowboard. A rate can also be expressed as money that you get paid for doing a certain job. And some of you might do chores or mow lawns for some extra money during the summer, and we're going to use the lawn mowing business as an example. Let's say that somebody mows 3 yards. And for those 3 yards that they mow, they get $30. So 3 yards for $30. We can set that up as a rate. So if I'm doing 3 yards for $30, I can set that up as 3 yards and I will make $30 for those 3 yards. And I'm going to go ahead and simplify that by dividing both the numerator and denominator by 3. And I will get 1 yard for $10. So that means if you mow 1 yard, you're going to make $10, and if you mow 3 yards, you're going to make $30. We're going to solve one last rate problem before we finish up, and I'm going to use my recent flight home to Pittsburgh as an example. When we were almost to Pittsburgh, the pilot made the announcement that we were going to be at the Pittsburgh International Airport in 20 minutes. After he told us how soon we would be at the Pittsburgh International Airport, he then told us that we were 80 miles outside of Pittsburgh, which meant that we were going to be traveling 80 miles in 20 minutes. We can set up these numbers as a rate to show how far that plane was traveling in a given amount of time. So we could set it up as 80 miles, and we'll use the abbreviation for miles as MI, in 20 minutes. And then we're going to go ahead and simplify that. Now, 80 and 20 have a common factor of 20, so we can actually go ahead and divide both of the numerator and the denominators by 20. And 80 divided by 20 is 4, and 20 divided by 20 is 1. So this plane actually travels 4 miles for every minute that it was going to Pittsburgh.